Hi everyone. We are still continuing with our logical operators. In the previous video, we were doing logical operators and we did the introduction to logical operators. So now the goal is to continue with where we left off. So the next item that we're going to focus on is logical not operator. And that's pretty much what we're going to look into and discuss together. Where were we here? Okay. Okay, we were here to begin with. And okay, I do not even remember these notes, so I'm just gonna comment them out like that. Okay, see you later, guys. Cheers. Okay, so a logical not operator, what is it? Okay, Log logical not operator. Well, the symbol looks something like this. Okay, I tapped the wrong thing there. That's what the symbol looks like. Well, let us define it like we usually do. I think the first thing that we can talk about is it a binary? What type of an operator is a logical not operator? To my understanding, is a prefix. Without even looking at it, I can just already tell that it's a prefix unary operator. That's the first thing that I can tell about it. The logical operator inverts a Boolean value so that true becomes false and false becomes true. So I like the kind of wording that they use here. But anyway, does it return a value? The answer is true. Does it return a value? True. Oh, yes, it does. Not true. Yes, it does. Yeah, it does return a value. Okay, so we just said it's a prefix unary operator. It does return a value. So, but then, as much as we talk about this as a unary operator, the symbol itself can mean different things. For example, if I do this here, if for example I say var, and then I say my optional, okay, which is of type string, optional, okay, I can just do this. If I do this, if I say print my optional, I'm going to get a nil. Okay, I can get a nil. But then if I do this and I force unwrap this optional, but look what symbol I'm using. I'm using this exclamation mark. So I think what's interesting here is to keep in mind that this symbol here has different uses. It's a logical operator when it's a prefix, but then it becomes a force. What is this? A force unwrapping operator, if I'm using the right term, when it's a postfix operator. That's one of the things that we can talk about. For example, I cannot call this a logical not operator, which inverts a boolean value. So those are some of the things that we need to keep in mind here. So at this point, it's a prefix operator, and this is its definition. If you make it a postfix operator, it doesn't work anymore. It's a completely different operator at all. Okay. But then if I say var my boolean value, and then I say not true, then we know how this is going to function. So now what's also interesting is that this prefix operator functions only or works with boolean values. We cannot use this var my boolean value true. We cannot say not 3. It shouldn't even make sense. Okay, int isn't a boolean value, right? Because it does not return a true or false. That's the thing about it. Even if I put it as 0 here, it still won't work. Because remember with C++, you can just put a 0. A 0 and a 1 means two different things, okay? So that's it here. That's one of the things that we learn about this. Let me remove the error. I like how they say it here. A logical not operator inverts a boolean value so that true becomes false and false becomes true. The logical not operator is a prefix operator. That's one of the things. And appears immediately before the value it operates on without any white space. I like how white space characters mean something here with Swift, because somewhere white space characters do not mean what we think they should mean. It can be read as not a, as seen in the following example. Let allowed entry is equal to false. Okay, is equal to, again, I want to get my tongue used to using the word assigned, even though it because we're not comparing, we're assigning. Anyway, I'll get my tongue used to this. Let allowed entry, okay, in other words, assign false to allowed entry. It's different how you read it from here going this way. Because I say let allowed entry be assigned false. Oh, we can read it that way as well. But anyway, sorry. If allowed entry, okay, print access denied. If, because we know the value that is here is false. So in other words, false, and then you use this symbol which inverts false to true. In other words, if true, print this. That's pretty much what it does, because it inverts this to false and then it returns a true. So in other words, if true, print this. Therefore, print access denied. Those are some of the things that we can see about it. The phrase if not allowed entry can be read as if not allowed entry. Okay, I just read it that way, but it's fine. The subsequent line is only executed if not allowed entry is true. That is, if allowed entry is false. Okay, it's interesting how we just played about with it like that, but anyway, it's fine. As in this example, careful choice of Boolean constants and variables names can help to keep code readable and concise while avoiding double negatives or confusing logical statements. Okay, so I guess I like that. Should we just jump to the next video and just do logical operators as well? Logical AND operators, since they're very few, so I think I'm gonna just cover them right now. How many minutes do we have left? Okay, the video has been on for like 6 minutes. I think I'll just do everything and then just finish it like that. And then we have logical AND operator. The logical AND operator creates logical expressions where both values must be true for the overall expression to be true. Okay, I see that. I think we discussed it even in the introduction of the video of logical operators. If neither value is false, the overall expression will be false. Okay. If either value, not neither value, if either value is false, the overall expression will be false. In fact, if the first value is false, okay, the second value won't even be evaluated, because it can't possibly make the overall expression equate to true. That makes sense. This is known as short circuit evaluating. It's interesting. I don't think this is the first time that we ever see this word short circuit evaluating. Let me control and find this. Okay, it has appeared 3 times. Short circuit evaluation with a non-nil here. Again, we have logical OR operators, short circuit evaluation. Anyway, but it's fine. I like how, anyway, it makes sense. I think it makes sense because obviously, yeah, it makes sense. And what's the nice thing about it is that because they did it this way with short circuit evaluation, is that it saves time with code and the compiler and many other things like that. So let's see this one part. This example considers 2 bool values and only shows access if both values are true. Okay, this example considers 2 bool values and only shows access if 2 values are true. Okay. Enter door code is true, pass retina scan is false. So in other words, this person entered a door code, correct, but the person didn't pass the retina scan, which is false. Therefore, we cannot allow the person to gain access to whatever building or whatever that's behind the door. So for that reason, it's false, which makes sense because, in other words, 2 things are required to be true in order for the statement to be executed. I don't know if I'm putting it the right way or not, but I'm sure I am. There's so many scenarios that can help explain this further, but then that's pretty much what it means with a logical AND operator. Now, what is the symbol of this? Okay, I didn't get to that part. Okay, let's look at the symbol of the logical AND operator. Okay, guys, see you later. Cheers. Logical AND operator. So the symbol looks something like this. Okay, and what kind of an operator is it? This is a binary operator. can never be a unary operator because it operates on two targets. Those are some of the things that we see about this operator. Does it return a value? And the answer is yes, it does return a value. What is the symbol? Okay, we talked about the symbol. The symbol looks something along these lines here. And what else can we talk about this? Okay. Okay, we talked about the symbol. We know it's a binary operator because it operates on two targets. It operates two targets or on two targets with through. Anyway, it's fine. For now, that's fine. Logical OR operator. That's the last part. The logical OR operator is an infix. But then, I just said it's an infix. Okay, infix meaning it can take place Why am I so confused now? I know what an infix is. Okay. Okay, I think I was using the word unary prefix, unary postfix. Now I see what an infix is. I think I thought an infix similar to this is similar to like this one. Okay, I guess I see where my mind was going there. But then why do they have to throw in an infix here and then not here? Because this is also an infix operator here. But anyway, it's fine. As long as we know that it's a binary operator, then we're good. Let me close you. Thank you very much. The logical operator is a binary operator or an infix operator made from two adjacent pipe characters. Okay, so there's no space between the pipes. It's one of the things that we see. You can use it to create logical expressions. Okay, these are pipes, by the way. You can use it to create logical expressions in which only one of the two values has to be true for the overall expression to be true. I see how there's three scenarios here. It's either you're false. Okay, it's either is a unary, a binary. But then anyway, how can I say this? Well, I see where the or will come from. I see where the or will come from. Anyway, it makes sense. Like the logical operator above. Like the logical operator above. The logical AND operator above. The logical OR operator uses a short circuit evaluation to consider its expression. So in the previous video, we came to learn that the short circuit evaluation is mostly based on the false. If it catches any false or any false is triggered, then the whole statement is evaluated as false. But then here with the logical OR operator, it focuses mainly on, or it targets, or I'll use the word it focuses mainly on the true. If a true is found or triggered or recognized or seen, then it evaluates the whole expression to true. And now when the whole expression is true, then obviously that's short circuit evaluation, because it doesn't matter if there's a false. You can have 10 false, 10 falses, but if only there's a single true and all of those things are using the logical OR operator, then it's going to evaluate to true. So let's see, if the left side of a logical operator expression is true, the right side isn't evaluated because it can't change the outcome of the overall expression, which is what we talked about there. Okay, I think it makes sense. For example, if this side is true, then the compiler shouldn't bother evaluating this side, because this side is true and it uses short circuit evaluation. In the example below, the first Boolean value has door keys is false, but the second value, knows override password, is true. Because one value is true, the overall expression is also evaluates to true, and access it's loud. Okay. Combining logical operators. Okay, let's see this one last thing. You can combine multiple logical operators to create longer compound expressions. Okay, now this is where it gets interesting. Does it evaluate from this side to that side, or does it evaluate from this side to that side? Now, I think they gave us a hint here. there's an if somewhere here. Let's look at the if. If the left side of a logical OR expression is true, so which means this thing evaluates it mathematically. You know how with maths we start from the left to the right. We start from, for example, we start from the left to the right, or whatever the precedence is. If there's a bracket, then obviously we're going to start with the bracket and then follow the precedence of left to right. So I think the same applies here. It starts from the left to the right. Hence, it says if the left side is true, then it doesn't bother evaluating the right side or the side following the left side because of short circuit evaluation. So even here applies. So what the compiler is going to do is going to evaluate these two. And then, for example, maybe let's write it down and see how it's going to look when we work on it. Well, we do know that these things do not exist, but then we'll replace them accordingly. Okay. Cool. So now I just want to create these variables here. Var enter the dog code. Can I say it's true? I wonder if I can do this. I don't know if it's gonna work or not. Pass the retina scan. And let's say it's true. Has dog key. Say this is false. Nose override password. I say this is false as well. I don't know why I just said it's false, but it's fine. Is this gonna work? Let's see. Okay. Nope. Huh? Why does it work? Anyway, so I guess we can declare variables this way. You know, I think it's fine because how though? Anyway, let me not concern myself so much with the nitty-gritties of it, but we see that you can declare variables this way, which is I think it's simple because we know that all these things have variables here. But anyway, it's fine. So what is this gonna do? Right, it's gonna do this if, because we do know that let's look at the first variable here. If enter dog code is true, that's the first thing that it's gonna do, and pass retina scan is true, or has dog key is false. I wonder if these what is this? If these operators have some precedence, because it'll be quite interesting if they have a precedence, because we know that with, for example, mathematical operators, they do have some sort of precedence. You cannot. Okay, I'll explain what I mean. What else? Nose override password is false. So that's pretty much what we have here. That's our. So this is what I meant by precedence, if they do have precedence, because we know with a mathematical expression, if I say var maths test, okay, why am I so okay? Maths test 2 times 4 plus 3 divided by 8. Okay, we know the way this is going to evaluate is going to say 2 times 4, and then it's going to evaluate 2. What is 2 times 4? 2 times 4 is equals to 8, and then it's going to say 4 divided by 8. Now what is 4 divided by 8? That is 1 over 2. Okay, that is 0.5. And then once it's done doing that, that's when it's going to add these two things. So our final answer will be 8.5, which if we try to check here, we should see 8.5. Okay, it says 8, but then I didn't declare as a double. 8.5. Okay, cool. So which means by default, this thing is declared as an integer. It's inferred to be an integer because, I mean, it makes sense. I didn't put any comma here. If I do this and I do not infer, but what is this? I do not, I forgot the term. What's the term? Comeback term. I forgot what the term is, but anyway, it's going to come back when it comes. Then now I can evaluate to 8.5 because it infers this to be of type double. Why is declaring a variable with a type? Anyway, why am I forgetting the term? Anyway, it's fine. It doesn't matter. So I wonder if the same is true with these here. Is it going to start with true and true? Or is it going to start with false and false? And then false and false? And then true? How is it going to work itself around? Let's check it out. I know there should be some precedence here. Okay, so here is the precedence. The Swift logical operators and, or are left associative, meaning that compound expressions with multiple logical operators evaluate the leftmost sub expression first. Okay. Now I think that's where I think they have equal precedence. I think all of them are equal, so which means it doesn't matter where the or is. Well, it does matter because of the location of thing. Does it make sense? But then according to this, then it means let's try to see if we're gonna get an answer or not. Now we want to see, is this going to print? If this prints, or is this going to print? Okay, let's check that. So then what's gonna happen is it's gonna say the first part is this: true and true evaluates to true. Okay, and then we're gonna have false, and then we're gonna have false. And then the second part is true or false evaluates to true, right? And then we're gonna have something like this. Let me do this to begin with so that we can see where we started. True and true, false, false, okay? And then lastly, true or false evaluates to true. So if we did this correctly, then that means welcome should be displayed. Let's see. Ta-da! So we can see welcome is being displayed here. So those are some of the things. I guess these things have equal precedence. It doesn't matter whether it's not gonna start, but then except now what will happen if we do this? If we do this, obviously the story is quite different now. Now the story is quite different because now it's gonna give us an absolutely different thing, because now we are making these start first because it takes precedence of the brackets. So that means true or false is true. True or false is true. Okay. Okay, true or false is true. But then now, if I do this, what's going to happen now? True or false is true. Okay. And then false or true is true. So ultimately, we're going to get a true. So now, does this matter how you place these things here? Well, I think they do matter, because if I did this, how would it change everything? No, I don't mean to take time here, but then I want to understand if they do matter. Okay, I want to see if these two statements are different or not. Okay, true or false returns what? A true. And then true and true returns what? A false. No, true and true returns a true, because it will have evaluated true, and then true and false returns a false. Okay, so those are some of the things that we see here. But then what will happen if I do this? Now it's a different story. It's going to say false and false returns a false, right? And then true and true returns a true, and then true and true. Okay, now I see. Well, the statements will be slightly different. For example, if I do this, okay, we see the last two are false, and then the first two are true. So then, if then I do this, I put brackets here, it's gonna change the output. It should say access denied, but it says welcome still. Oh, well, another reason is because I had this here. Now it's gonna change. Let's see. Oh, let me run it from here. How come it's still saying access? How come it's still saying welcome? Because we know this is false, this is false. False and false evaluates to false. Well, that's because there's a true here. Now let me check if I do it this way now. what's gonna happen? It says welcome still. I think the reason is because there's a this. Yeah, I think that's the reason why there's this. And because that means in order for this to evaluate to false, then I just need to make this a false, then everything is now going to evaluate to false. Access denied. But then can we make this evaluate to true? How would I do that? Then I just need to add brackets here. But then that's false and false has dog key. And it's always going to evaluate to access denied, then has dog key. I can make this true, which is still going to say access denied. But then what happens if I remove these now? It's still going to say access denied. Anyway, it's fine. I think we get it. We can figure out how that works. That's fine though. But then I think we do also understand that these things can take precedence. Once we put brackets here, they can take precedence. Okay, I think the best way to do this is an AND. If there's any false, if there's any single false, it's always going to evaluate to false. But then that means there should all of these things here should be true. No, but it's fine. Okay, let me say true. True. Let's see. That's welcome. Now it's welcoming, fine. But now let's say this was false. Now it's going to evaluate to false. Okay, cool. Now you can evaluate to false, but then either way, the only way for this to evaluate to true is to put an or here. And even if we put, what is this? We have this start first, either way. Oh, now I can evaluate. It evaluates to welcome, because either way it's going to say true, and true is true, true and true. Wait, true and true is true, true and true is true, and then true or false is exactly what we need. Okay, anyway, it's fine. I don't think the order and the precedence of this matters. I don't think so. And I don't think putting brackets here really makes a difference. I just don't think so. Anyway, I don't know yet, but it appears that it doesn't. It appears that it doesn't. Because either way, the order of these things doesn't matter, because all the operators have equal precedence. So if that is the case, then the order doesn't matter. I can put this here or there. So then it doesn't matter. It doesn't matter. It evaluates differently if there's precedence between the operators. So it doesn't matter. I think that's what I'm concluding to here. I don't think it matters. But anyway, I don't think it does though. I don't know if I'm right or wrong, but I don't think it does. This example uses multiple AND operators and OR operators to create a longer compound expression. However, the AND and OR operators still operate only two values, right? So this is actually three smaller expressions chained together. The example can be read as, if we've entered the correct door code and passed the retina scan, or if we have a valid door key, or if we know the emergency override password, then allow access. Based on the values entered door code, pass retina scan, has door key, the first two sub-expressions are false. However, the emergency override password is known, so the overall compound expression evaluates to true. Okay, so I think we're going to end it here for now. Thanks everybody for tuning in, and yep, it took longer than we expected, but I think it's meaningful though. At least we did something meaningful. Okay, cheers, have a good one, bye.